arrival of Colonel Hole. Yay!
Could probably legitimately just automate the announcements now. Set it for when a kernel hole is coming up, similar to how Space Weather Live does it. And then once you got it center disk, be like, in 3 days, it will be this.
Yeah, pretty much.
Like, really, we haven't needed much human input at this point.
I don't know if this actually
I mean, the
works.
size of it changes a little bit, and when I saw that the size is a little bigger compared to the last rotation, I'm like, well, where we are at Surge.
All about that shock. So let's see what happens. Also, I think it said it was streaming. It's YouTube.
Well, I think,
Yep.
so the thing is, when I try to schedule it in YouTube, like you set up a separate thing, but I don't know how to get it from where you take that link and make sure that when I put stream to YouTube from Zoom, that it goes to that link. And I
Oh, instead of like a separate new one.
so I believe what it did is this is a whole separate new one.
That's super
But
awkward.
there's stream keys and stuff, and I think you can do it that way, but I don't have experience with using stream keys. But
Well, it's working. We're alive.
yeah, it's so what I did was uh
Oh,
on
and
the
it does say the one that's waiting.
on the other one, I was like, go here.
Are you looking at this one? You're at the wrong page. Only because we can't do the same two. Well, let's see. I mean, I don't see any older link,
No, is it the same?
and I think it's the same
Okay, let me see if
because it also had the people waiting,
okay, maybe it is the same. I don't know.
and it has us talking right now.
Oh my God. Okay.
Indeed.
Uh,
Ah, it's Justin.
okay.
Yay!
All right. Well, I put the link in the one that I think is there. Because like right now it says on the page, it's like connect streaming software to start preview, and I'm like, okay, no. So I am just going to now watch me close this one, and then it like
And then
closes everything.
the plug gets pulled.
So yeah, we'll just casually chit chat for a little bit because I don't think I did that right. But I made it.
Keeping the unplugged and unplugged.
I made an
As
attempt
usual.
because that's all I ever do is make attempts. So
Plug gets pulled.
yeah, all right. Okay. I think it's there. Okay, I think everybody's there. Okay, good.
That worked out.
I'll just type in there. Like I think we're all here. That's the most embarrassing thing because I'm like, I should know how to work this stuff, but it's just not my thing. Like I'm not a streamer,
And that's why we're unplugged.
so it's difficult for me.
If
Um,
you knew how to do this and you had a bunch of cool stuff up, we'd have to, well, first off, we'd have a bad name.
yeah, yeah, we would have a bad name, you know. So it's okay, but it looks like people are here, and I'll get it up in the background on my phone so that way I can monitor the chat at
More
least.
unplugged than usual.
It's like, I just wish if I had my other setup at home. I because really it works better to have a dual screen
It
for
does.
this type of thing, and I don't have that.
I
So
mean, you might be better off just figuring out how to do it as far as the actual services from the laptop.
I know.
A majority of the streams seem to be from there.
Yeah, it does. Somebody is gone all the time. I'm
Well,
still
we're doing the
gone.
best we can. So,
Yeah,
nope, things are good.
For a
yeah.
free stream once a week, I'd say it's pretty good, yeah.
Yeah,
Yeah.
it's at least nobody's paying for this service. Anyway,
All
so
right.
we'll get going here because I think we have enough people watching. So today we are going to talk about EPAM and it's how it can be helpful, but not. helpful and some examples on, why you got to use it with caution or use it in conjunction with the various other things we have out there. Don't use it as like an end all be all to, what's happening. And then we're going to talk about current events because we do have a couple things to talk about. I mean, the sun's been kind of quiet, but we have an eruption that happened today, actually two of them. Um, Filament eruption and one from a sea flare and coronal hole. So it's interesting. It's interesting enough to warrant to talk about.
At least
So
given the things we've been given the last since October.
yeah. So we'll start off. I think we're starting out with current events, correct?
Yep.
Yes.
Okay. So we'll get that going. And I pass it over to you guys to get it going.
All right, I will be doing the EPAM talk. So if you whoever wants to cover the current events, I have
Oh,
G Helio viewer up if we need it
yes,
to
you
for that
do.
time frame.
Yes. Yep.
Bring it
So
up.
that's that. Yep. Bring it up. So,
Let's jump to 211. All right, this
yay.
is
That's
a
today.
what did I do time frame? Basically the last 24 hours almost of
Yeah.
activity, which just barely incorporates the three eruptions that we just had,
Yep.
which I'm just gonna run on repeat.
On the loop. So we had a few events
All right.
happening, and one of them probably was a little surprising for people if you have Space Weather Live and get the alerts. Everybody got the Type 2 sweep. So where was it coming from? Because there was no flare, and yet there was. It was, I think, C 1.3 flare, so
Little baby.
barely there.
Boom.
Yeah, there you go. So that generated a CME, which is of course not going in our direction. It's going to be passing behind, right behind our orbit. It's going eastward. I need to remember. Yep, there we go. Beautiful eruption. So of course
Right.
there was a Type 2 sweep because that's generated when the reconnection actually happened. And yay, right there.
Nice little plume coming out.
Yeah, yeah. So that tells you that sun is still capable of producing CMEs and some flares even at the low level. So C flares can generate CMEs. It just we usually want something more energetic, something directed our way. Then we had another interesting thing that happened. So as we have discussed several times, there are tiny, tiny active regions
Let's
within the
do
coronal hole. And this area,
actually
it's
running a
not
little bit.
active region. It's just an area of quiet sun that has a filament in it. And I think that filament actually erupted. And because
It's a
it's a,
pretty quiet filament too. It's really hard to find even in, well, the details here. I mean, this is
yep,
running differential and there's almost nothing there.
yep,
So let's go none, but just to throw on the actual sunspot layout too.
there's
Nada.
no sunspot.
Nope.
Nope. It's quiet sun with a bit of filament. And I think things are very complicated in that area because we do have sectors of opposite polarity in that area. So filaments like to live at the neutral line, positive to and negative on the border of those sectors. So that was probably one of those filaments erupting. Um, it is sort of embedded in the coronal hole. It's sort of peninsula within the coronal hole, so chances are it's going to be picked up by fast solar wind and fly in our direction. Am I expecting a lot from this? Not really. We might see that small sort of baby CME, a little bit of the smoother rotation and more persistent BZ pattern from it, but that remains to be seen. Again, as far as are we going to see it in LASCO? Probably not. It's just way too small. But can it generate something within the solar wind? Probably. Anything major? No. It's still going to be fast solar wind that's going to be driving majority of the picture.
Oh,
So,
there we go. Yeah, it looks a
yeah.
little bit better in the chromosphere. You can actually see the filament left off. So I just
Yay!
increased the cadence, but yeah. Thanks for that advice on that note, Marco. He said you could
Mhm.
see it in Gong, so I'm like, oh, duh, let's go ahead and check the chromosphere.
Marco is awesome.
Yes, indeed.
Although it's going to take a second to load through there. Yeah, I did see at least you could see that it's a filament liftoff from here. The Corona had a very meh impression from it, but although it'll take usually a couple years for just 1,000 frames to load through on here.
It's just 1,000. Whatever.
Yeah, by the time
Yeah,
the
I probably
frames
don't
will
need my
load, we
cadence to
probably
be 1 minute, but here we are.
no, but by the time it will load, I think that filament will arrive.
Yeah,
So
more than likely.
so we got one little bump. We'll see if it shows up in the fast solar wind. And previously, that coronal hole was generating winds about 700 kilometers per second. So it's a fast one. And we should be starting to see something probably within a couple of days,
Yeah,
looking
I'd say
at the
I mean,
border
yeah,
of
the
that.
leading edge of this, it's well almost to Earth. I'd say a day or two easy for at least
Mhm.
some sign of density increase. Although it looks gappy, so I'm wondering what that's going to end up looking like. Waves of shock.
It's gappy and there are positive polarity regions and sectors embedded into this wholeness. So
yeah.
it's gonna be interesting for fast solar wind. We're not probably not going to see very clear
Oh,
sector
nice.
boundary crossing, but who knows?
Well, there's the
We
first one
shall
at
see.
least.
Yep,
A little more aesthetic looking in
Look
the
at it.
chromosphere too.
it's beautiful. Small.
Then moving back over
It's
here,
pretty.
should almost be loaded for that.
Almost.
Oh, so close. Come on, just 400 more frames.
You can do it.
Come on. We waiting for you.
I mean, we could actually bring up the synoptic map if you really want to see the mess.
If someone has the ability to pull it up real quick, by all means,
Okay,
feel free.
I
I
can
will
back
sit here and
up.
I don't want to overload this and just load more things, so I'm going to stop sharing until that's done.
Yep,
Let's
I
see.
can do it.
We'll see who gets it faster. She probably has it on a.
I don't, but I
Okay. All right, I
can.
do have it.
Oh, okay. Well, I
Yay.
almost have it loaded now.
Okay, hold on. I'm
I
gonna
can see
share
the
it.
lift off.
There we go. Hello. All right, so here's the solar synoptic map.
Oh
It's
yeah, so it's
another
sandwiched in
another word
between
I
two
can't
positive
pronounce.
regions.
But it is weird. So like those little islands of positive polarity, like in between the negative polarity coronal hole. It's like this one's gonna be interesting to watch, to say the least. So I'll let that sit there.
There we go. All right, you can go ahead and
Okay. There you go.
unshare. I
That's
got it
the
up now.
synoptic map.
So what I am gonna do, let's try running and see how this looks on here. We should be able to see a pretty good signal. Yeah, there it goes. It's still, we need more contrast for it. Let's see. I mean, it's there, but let's make this darker. Yeah, that little bit there.
Look at
I mean, even the
it.
filament was tiny.
Mm-hmm.
My other assumption is, let's see, does it look like it comes back together?
I mean, I
Because
thought
it's
it,
hard to say if it was
yeah.
blown apart by the kernel holes to the north and south of it. No, it looks like it just got pushed back inward
This is definitely
for
one of
this
those ones
section of
to
it.
watch because it's a lot of those, stealthy things that end up in the
Hmm.
solar wind.
There'll definitely be something with it, I think. We'll see some sort of disruption or shock or something. Oh, and I guess while we're here, we can look at actual sunspots. Just kidding. There's no sunspots for me to look at. Now I have pretty steep standards for them, so the only thing I think that it is even worth looking at is the eastern limb right now. Or sorry, the western limb, and even then it's these are baby sunspots. They're nothing really to look at. Nothing going on central, some growth here, but who knows if that turns into anything. And then very much nothing in the east limb currently except some plages.
You,
This is
that's
looking like
all.
a sun like 2 years from the peak of solar minimum rather than a couple years from maximum. Not to say we're not going to see a swing again, but this is it's fun waiting this long for it to happen.
And that's that. There's our current events.
Yeah,
Yep.
pretty much.
All right.
Now we actually have a slide deck on EPAM. I want to momentarily at least bring it to current look on it because I think it's probably helpful here to explain what is actually being read here. I know we talk about levels and where EPAM is at, and if there's any increasing protons or electrons, but I don't think we've ever actually defined it, or have I heard anyone actually defined it. So this is looking at that fancy word again, flux, the actual flux of the protons coming through. This is take a square area, how many protons are coming through that square area at a given second. And that's basically what we're looking at here at different energy levels. The machine itself is a little complex. It's known as a Faraday cup, but it bends different protons with different energy levels, and they come in at different angles. And then the machine's able to analyze what speed or what energy in this case is coming into EPAM and then displayed here for everybody to see. Oops. So in this case, the red line is kind of our basis. This is the one that changes a little more regularly based on most events that happen in solar wind. This is the 47 to 68 KeV line, which is just a fancy way of saying it's a certain speed slash mass slash energy, all the same thing in this case. And then you have the orange one, which is 115 to 195, and then it just gets higher and higher energy. So the first thing to note is as you get into the higher and higher energies, and these are still low energies, even the highest ones. So the green line here, it's about 1 to 1.9 MeV, which is very, very weak in comparison to, let's say, the 10 MeV protons that come in that can cause the SEP events over an Earth. So this is still like just your low energy, not really much cause for concern, just more noting what's going on at the solar wind levels. But the point is, as you get higher and higher energies, the flux is lower and lower. So we get a very small amount of the higher and higher energies as you get down the line. Now, an example, the red one, we're at, let's say this is 10 to the 3. So this is 1,000 PFU. So 1,000 protons per cubic centimeter or per centimeter squared per second at this specific energy level, which right now is at 3. So 3,000 PFU is what I would technically call this at. And that means, again, there's 3,000 protons at the energy level between 47 and 68 keV coming into the scanner per second in that per centimeter box. So pretty technical, but it's really just a matter of keeping track of how many. And then this is the perfect example of your quiet, what I'm going to say is quiet ratings. So not much going on. You've got some zigzags here and there, but ultimately this line is almost always just barely above the 10 to the 3 mark. I don't really keep track of these ones down here because, again, they're kind of just mirror the lower energy levels. If the lower energies are increasing, then the higher ones generally will increase a little bit as well. So usually this is the more important one that I look at as more. Now, if Tanya, if you have the slide deck up, go ahead and
Yep.
pull that. But the point is, so this whole graph is to keep track of how many particles, and there's an electron section too. I just showed the proton one, but then we have one that shows electrons as well. Much less mass in those ones, but ultimately it's the same thing. EPAM games, I still love that.
It is fun. And that's
we
what
just,
talk
yeah,
about.
we just reviewed this.
Sure.
It's transequatorial, so it will impact. It's pretty much staring right at us, meaning it crosses the solar equator. All right, so let's start with the good stuff.
Okay, so the CME arrival one. So this is the one that literally everyone thinks is happening and always looks at and always freaks out about. You get these bumps in EPAM as, let's say, can we zoom in on this photo a little bit too? Is it like maybe
Probably
like
not.
150%?
Damn. Probably
okay.
not.
Let me try something on my end in that case.
Sure. If you want to share.
I have the slide deck open too,
Oh, yeah,
but I want
let
to
me
point at
stop.
specific things.
Yeah, let me stop sharing on this one.
Okay, no, it does not. So I will share it at least, but I'll be able to point at stuff.
Yeah, that's helpful somewhat.
Yep, that would be
There we
helpful.
go. Okay, so we have some standard, we'll just call this area what we were just looking at. It looks a little elevated based on the previous numbers we had, but it's hard to tell from there. But then we have this little shock and jump up here. So these are from flares specifically that occurred, I'm assuming, on the western limb, or at least close to it based on the shock. But this is your everything jumps level. Was there a SEP event on this one too? Let's see, S2 radiation storm. So this is a powerful one. This is one that was probably, oh, well, they're right here, M2, M5.
Yeah.
And was just in a good position to fire these protons towards us. I assume in this case, if we had shown the high energy one from GOES, that also would have gone up to S2 levels. But the idea is these here, these very, very sharp increases are always a sign of some sort of shock. And almost always that shock is accelerated electrons and protons from a higher energy solar flare, typically in a better connected region, so the western edge of the sun or around that area. It looks like then we had a second flare, same thing, which then caused the electrons to jump. Now, keep in mind, the protons themselves look different. They only had one shock here, and then they just stayed and continued to increase. Protons are far more abundant in these episodes than the electrons are. Electrons, generally, you won't see the flux change too often unless there's coronal hole involvement, or in this case, SEP events will also cause them to elevate. But they're much more clean, as you can tell. You have one shock, and then it decreases, then you have a second shock, and then it starts decreasing. These are still high levels, but no, very little involvement from the actual CMEs themselves. So we have the first shocks from the CMEs, and then you have the very, very slow rise. And this is where people would start freaking out about, oh my God, the CME is going to be close. Because as you get to this part where they start shocking upwards more, these are not from solar flares occurring. This is from the front edge of the CME beginning to pass. And as far as symbolically, what this means is you're getting more and more protons in that little tiny box that are starting to come by. So it's basically like a, well, I want to say a tidal wave, but I feel like that's still too shocky. But it's a slow increase of you're seeing more particles, more and more and more and more and more. So it's like snow getting thicker and thicker and thicker. And then as soon as you get up here, the CME likely would have passed in Discover or ACE in the solar wind data sometime just after the 24th, as I mentioned here. It would have been likely right around this time period. And then after we start seeing the shock pass through Discover and ACE, we get the decline in EPAM. This is what everyone looks for. This is the stereotypical characteristic of there is only CMEs at play, nothing else is going on. Pretty helpful to know when it's coming. Unfortunately, there is a lot of times when that's not the case. You can also get it for CME misses, which is a little more common when you get episodes that occur on the eastern edge of the sun, or if you get the magnetically confined ones that we seem to be frequently getting during center disk eruptions lately. Actually, really, really a lot of them. I feel like every time it's center disk, it's like only enough
Yeah, it
to
gets
then
deflected somehow.
deviate the other direction so it's away from us more. The sun hates us right now, I swear. Point is, though, here we have the actual flare occurring. You're not going to get much. This is still east of center disk. So as far as the actual proton involvement is concerned, there's very little. In fact, most of this was probably the flare in this region here. Not much of an increase, and it likely occurred much. Oh, this was actually on the first, so we didn't even have it on here.
Mm-hmm.
Oh, okay. I should probably read the time frame that we have here. So yeah, we don't have the actual flare, but so this would be when the wave as the CME is going, it's still pushing solar wind out of the way. This is the solar wind that we're getting pushed into us from the actual CME itself. Yet we didn't actually get any arrival in Discover or ACE. So all we're seeing is a gentle increase that then rounds off nice and then starts to decrease. There's no sharp edges. There's no giant jumps. It's just, okay, here's a wave and here's maybe another wave. And then that's that. Kind of like the tsunami that just went on with that huge earthquake, actually.
Yeah.
That's a fun comparison. And then we have the SEP events. Again, similar to what we saw before. This was a much more drastic one, it looks like. Still S2 level. I'd like to know the actual PFU level these got to. That'd be cool because, it could be 150, it could be 800, but the 800 ones could be far more impressive. But this is what the SEP events look like. It's a sudden increase in everything. It's high energy UV, gamma rays. I mean, we get that from any edge of the sun, but from the western edge, we're going to get also the electrons and the protons. And again, if you look at GOES, we have electron flux monitors and proton flux monitors. Those are also going to be increasing very, very shortly after these ones. And I do mean very shortly. It's usually just a few minutes. Now, these protons and electrons are generally traveling anywhere between 80 to 90% the speed of light, usually, as another fun fact. Shockless CMEs, those are my favorite, where we
Yeah,
just
these
have
are
them
these are fun.
embedded. And these are more common too, I would say. You get them embedded into the solar wind. They're kind of coalesced nice and neat with the ambient solar wind that's before and after it. So you get no real sign that anything is passing by whatsoever, but yet you still get an IMF BT increase and then a clear flux rope in this case over here, just because it's in that solar wind stream. But yet EPAM registered basically nothing. And this is essentially saying that there was no discontinuity in the solar wind between the magnetic fields. They all blended together nice and neat, and this is kind of how it looked. This is, I would say, the least chaotic version of a CME that you can have, at least in space. It's weird to think that something so chaotic and big like a CME can then just get embedded into the solar wind that comes to us naturally. And then we have complex events, and these are the ones that get everybody. And I do mean everybody, and I'm looking at you, Discord. So if you
Twitter.
ever have any of these giant bumps and then they go down and then more bumps, we could have, let's say, coronal hole influence. We could have multiple CMEs going on. We could have no real cause whatsoever, to be quite honest. There are other possible explanations, such as, I'm going to come back to that one. But you can have, say, slingshotted back protons coming back from the magnetosphere. You could apparently have Jovian ones as well from actual Jupiter firing them this way. Jupiter has its own magnetic field as well. We've got the sun's magnetic field everywhere. Everything's interconnected with this. So things going back and forth is also very possible. But these giant ones, especially, these are, I'm going to call them glitches just to be safe because let's be honest, the actual reasoning for what they are don't matter. They're not relevant to our aurora picture, at least. So these are what a lot of people start freaking out. Oh, you have this increase, like EPM's jumping up, and then 5 minutes later, it's jumping back down. Don't freak out over every jump up. It's all about the trends. You're going to want to look long term, 20, 30 minutes. Is it still increasing over 30 minutes? Then you might have something coming or going on. But if it's not, it's just a random glitch in this case, which again, we can find a cause for it, or at least find causes that could be, but we're never going to know what the actual causes are for. Oh, probably should have kept that
You already
this screen first.
you
Here's
already
the answer
feel the
first.
answer.
Yeah.
Yes.
Point is though, so let's, if we were to look at this one time period, we at August 13th, so this would have been then the 14th. What's the cause from this? We have electrons being flat. We have protons jumping up, all of them at different levels for different amounts, and then going back down to flat, and then starting to jump more along with the electrons. So
And
what it,
that was actually sent to me by Les. So thank you for the daily challenge.
ah,
Thank
Yes.
yes,
you.
thank you, Les. Looking out as usual. Well, as maybe you guys saw, none of the above. There was nothing going on in that particular area. We could not associate this with anything, especially this giant jump. Let's see, the white is set, we'll say 800 to 1.1 MeV, and that jumped up to almost 10 to the 5 from its baseline of 0.01 usually. So a literal 100,000 increase in just a minute or two. That's not going to be real. Or if it is real, it's not going to be relevant because it's come all the way back down and back to its normal levels.
Yeah. So I can probably talk a little bit more about those glitches.
Oh yeah,
So
let's go.
glitches are fairly interesting. So ACE does not have a sense of direction as far as where particles are coming from. But wind and a couple of other satellites actually do. So we can figure out where particles are coming from and whether or not they're looking different between close to the bow shock. So that's the border of the magnetosphere and sort of solar wind out there. And further out into solar wind, actually further closer to the sun, so more upstream. And those spikes are actually coming from um, somewhere from Earth or potentially from other planets like Jupiter, which has gigantic magnetosphere. But again, they are anti-sunward, so they're traveling toward the sun. Those events can affect both protons and electrons, although electron involvement is less common. And that was initially seen as, well, those electrons are not enhanced, so there's probably just they're coming from the shock. So shock can accelerate particles in both directions, and they could be sort of bouncing away at higher speed. But magnetosphere is also leaky, doesn't contain all the particles. So when you think about substorms, when both electrons and protons are accelerated toward, well, if through the reconnection process, some of them um, fall out of the sky, literally, and generate aurora. Others actually escape magnetosphere. They gain enough speed to escape the magnetic trap, and they start to go in all possible directions, including L1. So it could be coming from the substorm. It could be coming from the shock. And they can be fairly commonly seen during high speed streams because it's more of a radial field, meaning it has a certain direction, so it starts to interact with different areas of our bow shock, our magnetosphere, and then particles start to go in the directions where they came from, literally.
That's
So,
pretty
but it does
interesting.
generate errors in solar wind data, which we see. So, meaning it's not related to solar wind. And solar wind has to be corrected in terms of temperature and speed when we start to see those events. So sometimes you can see arrow markings with low density and sort of all sorts of spikes. But typically there is an algorithm to correct for those in the solar wind.
Unless it becomes so overwhelming that it's unable to. So ACE in particular, if we start seeing usually S2 to S3 levels, the solar wind data becomes unreliable completely. That's density, temperature, and speed. They all go kind of wonky. And that's been
Mhm.
kind of a bad sign with ACE since to my knowledge, since it started. Since it's all we have now, then it's helpful to keep in mind that that's what's going on. If we get high flares in those SEP events, then we start losing the ability to really know what the actual data is. I believe there's a way to actually recover that because they were able to do it for the October event back in 2003. Even though we had actual solar wind data go out, they were able to get a good estimate as to what the speeds ended up being at. But the point is, it makes data unreliable, and then you also get snow in LASGO imagery or imagery in general that is exposed to the high flux rates from the higher energy particles. So you get all of the white snow. Well, it looks like snow in the coronagraphs that we have with LASGO, and those are the high energy particles slamming into the detector and causing streaks, which is a lot of fun to look at, but
Yep.
also makes it harder to see if there's a lot going on. It can really blur the picture quite a bit.
Yeah.
But those spikes are not the sign of ACE quitting or going bad. It just means there's a lot of interference with measurement going on. So ACE is still going strong and pretty much the only spacecraft out there that's monitoring solar wind in real time. So have have some tolerance for errors that you see. It's not generated by ACE, it's generated by solar wind and all the things in interplanetary space. ACE is just fine. It's measuring what it can.
Yes.
And
So
then
here,
kind of the summary
yeah, here's our
post.
summary for you all.
So we have the shocks mostly causing the EPAM rises sometimes. Otherwise, it can mean CMEs coming towards Earth, passing close to Earth. We have SEP events that it could be just data glitches in general or actual causes from other sources. But the point is, there are very few events that are actually consistent and can tell us different things. In general, EPAM can't really tell us much, and there is no fixed, oh, well, this is rising in this way, therefore it is this. That's never the case. I think we mentioned it earlier. There is no Bible to this. It's you have to have your own interpretation of it in order to make any sense generally. Take what other solar flares have there been? Are there any other events coming through? There might be stealth events we don't know much about. It's really hard to justify other things not influencing the data you're looking at. So you can't look at each individual data sets and say these are the same because they look the same. Doesn't work that way. Oh, which I didn't even look at this one, funny enough. So I'm glad that we reached the same conclusion with these points. But
And SEP SUP events is solar energetic particle.
oh yeah, we did not define that. Good point.
Yeah. Solar energetic particle event. They're um they're not friendly to any sort of
To
spacecraft, really.
anything,
Yeah.
humans, anything that
Yeah,
is
anything.
organized and not chaos is it's
It
not good for.
causes problems.
Yep, for sure. They definitely cause more problems in orbit, sort of in
Yeah.
higher levels of atmosphere, but they can affect airplane crews and passengers. So higher SCP events, you're definitely getting a little bit more radiation than you bargained for. Some of them can penetrate all the way to basically Earth, and they can cause glitches in electronics, which is kind of fun. For me as a medical professional, I know those energetic particles, high energy particles, can actually cause all sorts of device malfunctions, including implantable devices. So defibrillators, pacemakers, other implants. So anything that's completely implantable and very difficult to access from outside, I kind of don't want that in my body because we have a lot of stuff flying from space.
Especially
I
on
want
planes.
something, yes, I want something. Actually, flying by plane increases the risk of device malfunction, implantable device malfunction, by about 20%. So most of them happen on Earth. And those devices, so if you have a device implanted, rest assured that most of the device manufacturers are very well aware of it, so the device will be put in safe mode. It still will be function, but maybe not fully. But the best way if something is off is go see your medical professional because they can reset the device and get it back to normal operations. But there are case reports of fairly wild stuff, including pacemakers not functioning as intended, meaning they're just in the safe mode and they're barely keeping up with the demand, but they're still working. It's just the person is not feeling the greatest, but yeah. And of course, there's no database of those errors, so we really don't know the true incidence. That would be something good to have and know which devices are more susceptible. There was a
Be a good
huge
study.
bad year in 2005. We had pretty big ground level enhancements. Those are events when we have a ton of energetic particles reaching all the way to the ground level. And I think it was St. Jude that had to recall a bunch of devices. They were sitting on the shelves doing nothing. And just before implantation, they usually go through testing. So it turned out that those devices somehow went bad and drained the battery. So there's probably an energetic particle event that caused damage to the microchip, and those chips are tiny. And it just drained the battery. So those devices were explanted and changed to a different one. Obviously, a person who was discovered to have a device that was about to go in was getting a different device, but a few people actually had to get their devices explanted in exchange. So
That's
those solar energetic particles
yeah.
are not benign.
No, they just don't do anything for us for Aurora, but
Yeah.
they're problematic to say the least.
Yeah, we're lucky to have the magnetosphere that actually protects us from most of those
Yeah.
particles. So we don't have ground level enhancements, which is just major rain of very high energy particles that can affect us on Earth. But yeah, if you're traveling by plane or planning a trip in space, like, well, you've seen commercial space flights, there's going to be a question whether or not implantable technology is something that is safe to travel because the exposure is very different higher up compared to on the ground level.
Yeah, because you think about it, like in an airplane, you're at 30, 40,000 feet at most. Um, so it's not like you're high, but you're not that high. And you're still getting these, especially those polar flights, which they do a
Yep.
lot. So the transatlantic stuff. So yeah, it's just, something to keep in mind if you travel, fly a lot, like some of us do.
Check the space weather. You want to
Yeah.
be, yeah, you want to be looking for not necessarily aurora, but you want to look for
Mm,
what's going on as far as solar energetic particles.
yep.
But I think I was flying through S2 once. It was
I
kind
was
of
too.
interesting.
Yeah.
Yeah.
And I'm probably the only one on that plane that is thinking about that.
Yeah, probably.
Yeah, I don't assume that's an average thing for most people. No.
Fly the friendly skies, meet some friendly protons.
Yeah, it's interesting. So anyway, there's our PSA on the solar energetic particle events.
So stop getting freaked out over every single bump.
Yeah, of EPAM. But freak out on your transatlantic polar flights.
If there is S2 or
Yeah.
or S3 in place, then yeah, you definitely want to pay attention to that. But the thing is, with a lot of polar flights, they will reroute it
They will. Yeah.
if there is a solar energetic particle event. So they're not going to be flying through it. But if you have people in orbit on the spacecraft, there are some protection in place. They will go somewhere where they have a little bit more shielding, but they don't have the magnetosphere, or at least not as much of the magnetosphere protection as we do. They're still mostly inside the magnetosphere, but sort of outside.
Yeah.
Yep. All right.
Anyway, That's that's our
So
that's our stream for the day. Unless
Yep.
I'm thinking, let's see. I don't think we have any questions to address, which is good. Just lots of cool commentary. So I like everybody's commentary. So it's always helpful. On that note, I don't know exactly when we'll do the next one. Um, but yeah, my personal schedule this week is out of control. But so we'll shoot for next Sunday. Hopefully I think we'll do a car drop and hopefully maybe we can there's some in between there where we can get one of these in. But yeah. That's what I gotta say about that. This is gonna be my for me a challenge of a week because it's a lot of midnight shifts and then going straight
Oof.
to the day shift. So I'm gonna be a zombie to say the least. That's okay.
Sounds right.
Maybe there'll be
Yeah.
some Aurora to entertain me while I'm working midnights.
Well, we'll see what shows up in Solar Wind, whether or not
Yeah.
that flux rope will actually materialize.
You're right. So anyway, yeah. Yeah, so thanks for being here. And it looks like everybody liked the explanation, so which is good. Because I think we have to go over some of these things every once in a while because I think, with Twitter and stuff, it gets lost, that things need to be taken. You need to look at the whole picture, not just one thing, so that way you can tie these events together. Like if there's flare, like because a lot of times when you have elevated solar activity it's across multiple things. Like you have multiple flares going on or this and that. So it's like, so you do have to kind of take a step back and look at everything that's going on and then try to piece it together. And even then it can be kind of hard. But everything in this field is not easy.
Sounds right.
Yeah. So yeah, oh yeah, so the G1 watch, yeah, they did put a G1 watch out today, and probably for the coronal hole.
Yep.
Yeah, that's just standard at this point. If you see a
Yeah.
G1 watch that there's a kernel hole, that's kind of by default since the shocks can form G1s, even if it's a pretty weak
Yeah,
kernel hole.
and it doesn't even take that much.
Yeah,
So that's not surprising.
nothing to blink your eye at.
We'll see what happens with the little stealthy poof.
Poof.
We'll see if it enhances it at all. But on that note, I'll let you all have your evening back. So thanks for being here and thanks for tuning in, supporting our little cause. I'm glad to have all three of us here. It's been a hot second. Well, now
Yeah.
I guess the four of us because we have a cat
I was
that's
gonna say I got a cat in the way
that
right now.
is wanting
Yeah,
to.
that's gonna be our stealthy poof.
Yeah, our stealthy poof. The cat says, "I need attention right now."
That is exactly what this is.
Yeah, let's see, Janelle. The polarity being negative is not what we want yet. Well, actually, it's autumn positive is what we want. So positive polarity. But there's little positive. There's those weird positive bumps in between it. So I don't really know what to expect from this. We'll
Not
see.
a clue.
Um, we just gotta wait and see at this point because there is a lot of discontinuity between the polarities there. So we will see. We'll see.
It's the answer to everything.
Yeah, wait and see. A couple days. So you guys all have a wonderful evening now, and we'll let you get back to doing what you do. And if anything crazy happens, we'll try to do a emergency broadcast. But I might be at
Those are my
work. Won't
favorite.
be able to do it anyway. But we'll see what happens.